Hello, my name's Ben McLaren. I work at Carnegie Mellon in the School of Computer Science in the Department of Biological Sciences. My colleagues and I are developing software designed to help students learn to think like a biologist. The curriculum is based on an idea we have come to call pathway algebra. The software that implements this curriculum uses a technology developed at Carnegie Mellon called cognitive tutoring. I want to give you a brief introduction to the tutor that we have designed, which we call the Cognitive Tutor for Analysis in Genetics, or CTAG for short. First off, let me say briefly that I can't emphasize enough that genetics is far more than simply a subdiscipline of biology. Genetics is the logical foundation of all of the biological sciences. It's also central to understanding health in the 21st century, as well as many other economically important fields. So the main purpose of this video is to give you a brief introduction to pathway algebra, but also some of the lessons that we have in the Cognitive Tutor for Analysis in Genetics. So to use CTAG, the first thing that you need to do is go to Carnegie Mellon's Open Learning Initiative website at oli.cmu.edu and sign up for an OLI account. It's very easy, it'll only take a few minutes, and register for the CTAG course. The course key, which you'll use for signing up, is CTAG S19 Guest, which is spelled exactly CTAG, C-T-A-G hyphen S19 hyphen GST. So when you sign up for the course and enter, the first thing you'll see is this syllabus for the course. As you use the tutor, you're never more than a few clicks away from this screen, so you can get your bearings and find out where you're trying to get to more easily. So the syllabus is broken down into units, the highest level of organization, and each unit is further broken down into modules. Let's start by clicking the first unit, appropriately named Unit 1. At this point, we can click on the unit bar to see the other units and move directly to them. You can also beneath the unit bar, we will see other modules within that unit that we can jump to. So let's go to the first page in the first unit. The first page of the introduction summarizes the 4 big ideas from the College Board's AP Biology curriculum. Even if you're not taking AP Biology, these concepts are tremendously important for anyone who wants to understand biology in the 21st century. They are organized from the most basic cellular processes to the most encompassing evolution. The 2 most relevant to us here are 2 and 3. Interactions and information flow. Number 2, interactions, says that the cellular processes that make up biological systems interact and that complex properties emerge from these interactions. The different states of the components of biological systems can be thought of as representing information. Number 3, information flow, says that these cellular interactions are connected and that these connections form directed networks that interact according to specific principles to retrieve, transmit, and respond to information essential to all living systems. The molecules in a living system and all of the different make up what is referred to as the interactome. A full understanding of the interactome is the holy grail of 21st century biology. The Human Genome Project was simply the first baby step towards this goal. As you move on and explore problem-solving activities in the rest of CTAG, I invite you to revisit these first few pages from time to time to remind yourselves of these big ideas. They will start making more and more sense as you learn the concepts and practice reasoning about biological systems within the pathway algebra framework. On the next page, page 3, which I get to by clicking this arrow up here, we see an explicit statement of the philosophy which guides the core curriculum of CTAG, which I call pathway algebra. Much of what students do in traditional biology classes, far too often still today, is declarative and memorization intensive. Students watch videos and learn to describe what happens in transcription or other important processes, but there is much more to being a biologist than this. Some of this is necessary and very useful, but an over-reliance on this approach in teaching and instruction means that opportunities for deeper learning by doing problem solving are passed over to leave room for simply more stuff. Pathway algebra, in contrast, is an abstract logical framework for representing biological systems. So we teach several topics using this framework, and within this framework you learn to formulate models or theories of biological processes. And these models support learning of two problem-solving activities central to being a biologist: prediction and explanation, or experimentation. You can think of them as running a model forward or backward. Prediction involves determining what will happen or what you will observe if you know the underlying properties of the system. And explanation or experimentation is the process of inferring the underlying properties of a system given data and a theory of that system's behavior. That may sound complicated, but as students use CTAG, they come to see that as they come to see this idea as remarkably straightforward, or at least not as complicated as it might sound at this point. You will come to see pathway algebra as capturing the core thought processes of a biologist. CTAG attempts to put students in the driver's seat as much as possible, moving toward getting them to start building their own models of the world around them based on their observations of it. There are several statements or concepts that make up pathway algebra for biology. We call these postulates in much the same way that postulates form the foundation for geometry. They are based on key discoveries in the history of biology and are features of any area of study in biology. The most important organizing postulates here are the existence of two types of pathways. All systems in all biological systems can be thought of or represented as one of these two types of pathways or a combination thereof. From the simplest reactions all the way up to ecosystems and how organisms of different species interact with each other and the rest of the physical environment. The first type of pathway we call the assembly line pathway. These pathways take inputs and process them, building them up or breaking them down, or more commonly both in a coupled fashion, to get a required output. Example assembly line pathways include things from simple chemical reactions to much more complex processes like the Krebs cycle, glycolysis, fermentation, even transcription and translation. They all take inputs and produce the required outputs, mostly guided by enzymes or other gene products. The second type of pathway, we call it signaling pathways. These pathways are for communication and control. They involve gene products, usually proteins, that can be turned on or off in different conformations, for example, to trigger the next step in the signaling pathway. The different states of these gene products determine the output ultimately or the final signal in the pathway to turn on different genetic programs in the genome. So again, as I said, as the students use the tutor, these ideas which seem overwhelmingly abstract and complex will come to make far more sense, and students will learn to see this model of pathway algebra as a very, very general and transferable way of viewing living systems. So moving on to the next page of this introduction, we see a brief description of what the genetics cognitive tutor is. Then there's a pointer to a video that takes you through a few of the lessons and gives you an idea of how to solve problems in the cognitive tutor more effectively. Here's a brief outline of what cognitive tutor lessons, how they work. The basic idea is that there's a problem that is scaffolded or laid out for you with all of the steps in that problem, made explicit by text fields or pull-down menus, and then there is a help button that you can click on and get help and ask for more levels of help. There are several different levels of help at each step. You can go through this if you're interested. And the next page talks about what topics are covered in CTAG. There are currently 7 units that have been ported to OLI. And the most important ones, the most central to pathway analysis, are units 2 through 5, gene interaction pathways and epistasis and metabolic pathways, or assembly line pathways, I should say, gene regulation pathways, developmental pathways, and the development of the organism and development of an embryo, and cancer pathways. Each of these units has 2 tutor lessons. A forward reasoning, where you're predicting what's going to happen in a pathway if you know the underlying properties, and then a backward or experimental component where you're shown data and asked to run the pathway backward to determine what could have led to those observations. To sum up, we can use pathway algebra to teach the content of biology, but do so emphasizing the logic in biological systems that is so often ignored. For example, if we look at the logic that exists in commonly taught topics, students get a chance to strengthen their logical reasoning skills. When we teach advanced topics like cancer, a deeper understanding of them is made more accessible by reusing and extending the logic of pathway algebra first acquired in earlier lessons. Students come to seek commonality between areas where commonality has traditionally been ignored. We can learn to reason forward with models of complex systems and then apply some general purpose strategies to strengthen key scientific reasoning skills. I hope you get a chance to create an OLI account and try out CTAG. There are good reasons to believe why many people are coming to see it as laying the foundation for a revolution in high school biology education. Thank you for watching this video.